Hello there, and welcome to The Sleepy Scientist. Tonight, we leave the noisy world behind and set a course for the innermost realm of our solar system, a world of profound contrasts and eternal silence, the planet Mercury. In the vast, star-dusted theater of our cosmic neighborhood, Mercury plays a unique and understated role. It is a planet that orbits closer to the brilliant fury of the Sun than any other. Yet, it remains one of the most mysterious and calm bodies in our celestial family. It is a world defined not by what it has, but by what it lacks: an atmosphere, moons, sound, weather, and in that absence we find a strange and powerful beauty. Our journey will be a slow, meditative exploration. We will uncover 100 facets of this enigmatic world, but we will not rush. We will linger on each one, allowing its significance to settle in the quiet of our minds. Each fact is a brushstroke on a canvas, revealing a little more about this ancient world, its scarred surface, its peculiar orbit, its hidden magnetic forces, and the human ingenuity that has slowly brought it from a fleeting glimmer in the twilight to a world we can map and understand. So, make yourself comfortable. Let the tensions of the day dissolve into the stillness around you. Close your eyes if you wish. Breathe deeply, and imagine yourself gently untethered from the earth, floating weightlessly through the dark expanse of space. The blue marble of our home recedes, becoming a distant star, and ahead of you, growing steadily in your view, is a gray, cratered sphere, bathed in the unforgiving light of the nearby sun. This is Mercury. Though small and silent, it carries stories billions of years old, narratives of creation and endurance written in stone and ice. Let's begin our quiet voyage of discovery. Mercury is the closest planet to the Sun. Our journey begins with the fundamental relationship that defines Mercury's entire existence, its intimate dance with the Sun. Mercury orbits, on average, a mere 58 million kilometers from our star. To put that staggering proximity into perspective, that is less than half the distance between Earth and the Sun. At this range, the Sun is not merely a bright light in the sky, it is an overwhelming presence. Sunlight falls upon Mercury's airless surface with an intensity 7 times greater than what we experience on Earth. It is a light without filter, without softening, a silent, scorching blaze that pours directly onto the rock. If you could stand on the surface of Mercury at noon, the experience would be utterly alien to any earthly sensation. The sky above you would not be blue, but a profound, unending blackness, a perpetual midnight. Against this velvet darkness, the sun would hang, a searing white hole in the fabric of space, appearing more than 3 times larger than it does from our world. There would be no clouds to diffuse its glare, no air to scatter its rays and create a gentle blue dome. The light would be sharp and merciless, casting shadows so deep and black they would seem like cuts in the very ground. This relentless closeness is the architect of Mercury's nature, forging a world of impossible extremes, a delicate balance between the fire of a star and the cold emptiness of the void. Mercury is the smallest planet in our solar system. As we draw nearer, the first thing that strikes you is its modest size. Among the 8 planets that orbit our Sun, Mercury holds the distinction of being the smallest. With a diameter of just about 4,880 kilometers, it is even more compact than some of the moons that orbit gas giants like Jupiter and Saturn. To truly grasp its scale, imagine our own planet, Earth. You could fit almost 18 copies of Mercury inside it. It is a humble world, one that could easily be overlooked in the grand scheme of the solar system. Yet, within this small package lies a great surprise: immense density. Despite its diminutive stature, Mercury is surprisingly heavy for its size. It is a world composed predominantly of metal and rock, and scientists have deduced that it possesses an anomalously large iron core. This metallic heart is so vast that it accounts for nearly 85% of the planet AS radius. Picture a planet that is mostly core, with only a relatively thin shell of rocky crust wrapped around it. This hidden density gives Mercury a gravitational strength that belies its appearance. It is a compact world of significant weight and gravity, a testament to the fact that true substance is not always reflected in size. It orbits the Sun with a quiet, dense presence, a solid and resilient sentinel in the inner solar system. A day on Mercury lasts 59 Earth days. As we synchronize our perception with Mercury's rhythm, we encounter one of its most mind-bending qualities, the strange flow of time upon its surface. Mercury rotates on its axis with an almost imperceptible slowness. A single complete spin from one noon to the next takes 59 of our Earth days. This means that a single day on Mercury from sunrise to sunrise spans nearly 2 of our months. The Sun, that colossal furnace in the black sky, crawls across the horizon with a languid pace that is difficult to comprehend. This slow spin creates a profound dissonance with the planet's orbital period. Mercury's year, the time it takes to complete one frantic lap around the Sun, is a brisk 88 Earth days. Think about that for a moment. In the time it takes for Mercury to experience a single day and night, it has completed more than 2/3 of its entire journey around the Sun. This bizarre relationship between its rotation and its orbit creates a celestial ballet unlike any other. If you were standing on the surface, you would witness a Sun that not only moves slowly but also appears to change its mind. Due to the planet's varying orbital speed, there are points where the Sun seems to stop in the sky, reverse its course briefly, and then resume its slow trek. It is a strange, hypnotic dance, a silent performance governed by the immutable laws of gravity and motion, a display of cosmic mechanics made visible. Temperatures on Mercury swing between fire and ice. The consequence of that long, slow day is an environmental extreme that is almost unimaginable. Mercury is a world without a protective atmospheric blanket. It has nothing to trap heat, nothing to distribute warmth across its surface. It is a planet utterly exposed to the vacuum of space, and this exposure subjects it to the most dramatic temperature swings in the entire solar system. During the long Mercurian day, when the Sun beats down for weeks on end, the surface temperature can soar to a blistering 430 degrees Celsius. That is hot enough to melt lead, to render the very rock scalding to the touch. The landscape bakes under the direct glare, storing the stellar energy in its bones. But when the Sun finally sets and the long night begins, that stored heat radiates unimpeded back into space. The temperature plummets with a swiftness that is just as violent as the heat. In the darkness, the Mercury, a fitting namesake, drops to a bone-shattering minus 180 degrees Celsius. This is a plunge of over 600 degrees. This dramatic cycle of fire and ice happens not with the gentle transition of seasons, but with the stark binary switch of light and shadow. And yet, even here in this world of extremes, there are pockets of moderation. Deep within polar craters, in places where sunlight has not reached for billions of years, the temperature remains perpetually profoundly cold. It is in these frozen sanctuaries that one of Mercury's greatest secrets is kept: water ice. A world both scorched and frozen. Mercury teaches us a profound lesson about the nature of the universe, that even in the most hostile of environments, pockets of preservation can exist, and silence can be the guardian of surprising treasures. Mercury has almost no atmosphere. The reason for these violent temperature swings lies in the profound quiet that envelops Mercury. It is a quiet deeper than any found on Earth, a silence born of absence. Mercury possesses almost no atmosphere. What little envelope it has is so tenuous that it cannot rightly be called an atmosphere in the way we understand it. Scientists refer to it as an exosphere. It is a collection of individual atoms, oxygen, sodium, hydrogen, helium, potassium, so sparse that they are more like a fleeting cloud of dust than a continuous gas. These atoms rarely, if ever, collide with one another. The experience of standing on Mercury would be one of sensory deprivation in its most absolute form. The sky above would be black, always black, even at the height of day. No sound would travel, for sound needs a medium like air to propagate. Your voice would die the moment it left your lips, absorbed by the utter void. The only sensation would be the direct, unfiltered touch of sunlight on one side of your body and the deep radiative cold of space on the other. There would be no wind to stir the dust, no whisper of air past your ears. In this emptiness, Mercury's stillness becomes an almost physical presence. It is a true vacuum, a world where heat and cold, light and darkness move and interact without resistance. A pristine laboratory of physics operating on a planetary scale. Mercury's surface is covered in craters. As our imaginary spacecraft begins its orbital pass, the view that unfolds below is one of ancient, battered grandeur. Mercury's surface is a testament to endurance, a landscape frozen in time. It is covered, much like our own moon, in a countless array of impact craters. These are the scars of a violent youth, the pockmarks left by asteroids and comets that bombarded the planet during the early, chaotic days of the solar system over 4 billion years ago. For billions of years, these craters have remained untouched by the forces of erosion that constantly reshape the face of Earth. There is no rain to wash them away, no wind to smooth their edges, no tectonic activity to swallow them whole. They are a permanent record of cosmic violence, now silent and serene. One of the most magnificent of these features is the Calorus Basin, a colossal impact crater that stretches approximately 1,550 kilometers across. To stand on its rim would be to look into a basin so vast it could swallow entire countries. It was likely formed by a cataclysmic collision with an object the size of a small moon, an impact so powerful it sent shockwaves through the entire planet. From orbit, these craters create a landscape of mesmerizing texture and shadow, a gray rolling terrain of circular ridges and deep basins. Mercury's face, though rough and deeply scarred, tells a story not of fragility, but of incredible resilience, a world that has weathered the storm of creation and emerged quiet and enduring. Mercury has a large iron core. Beneath this scarred and ancient crust lies the source of Mercury's surprising heft, its enormous metallic core. When scientists calculated the planet's density, they found it to be the second highest in the solar system, surpassed only by our own Earth. This was a puzzle. How could such a small planet be so dense? The answer revealed a hidden interior structure that is unique among the rocky planets. Mercury's core, rich in iron and nickel, is disproportionately massive. It is estimated to make up a staggering 85% of the planet's volume. Imagine a planet the size of Mercury, and then imagine that almost the entire thing is a ball of molten and solid metal, with only a relatively thin, rocky shell, perhaps only 400 to 500 kilometers thick, encasing it. This is Mercury. Several theories attempt to explain this strange anatomy. Perhaps Mercury formed from material that was naturally rich in metals close to the Sun. Or, more dramatically, it may have suffered a gargantuan impact in its early history, a collision so violent that it blasted away much of its original rocky mantle, leaving behind the dense metallic heart. This hidden core is the source of Mercury's gravitational strength and its weak but detectable magnetic field. It is the planet's true self, compact, resilient, and quietly magnetic, a world built around an unseen core of immense power. Mercury has a magnetic field. The presence of a global magnetic field was one of the great surprises revealed by the Mariner 10 spacecraft in the 1970s. Given Mercury's small size and slow rotation, many scientists had expected its core to be completely solid and geologically dead, incapable of generating a magnetic dynamo. Yet, Mariner's instruments detected a field, weak by Earth's standards, only about 1% as strong, but unmistakably present. This magnetic field is a clue, whispering secrets about Mercury's interior. It suggests that at least part of that massive iron core is not solid, but remains molten. The motion of this electrically conductive liquid metal, churning slowly in the planet's heart, generates the magnetic field through the dynamo effect. This faint, lopsided field, though weak, is not insignificant. It interacts constantly with the solar wind, the torrent of charged particles streaming from the sun. This interaction creates a small teardrop-shaped bubble around Mercury called a magnetosphere, which deflects some of the solar wind and traps particles, creating invisible magnetic tornadoes and subtle auroral phenomena. Even in the profound silence of space, Mercury hums with a faint electromagnetic energy, a hidden dynamic life force pulsing within a seemingly inert world. Mercury has no moons. In its solitary journey around the Sun, Mercury travels utterly alone. It has no moons to grace its black sky with their soft light, no rings of ice and dust to catch the sunlight in a celestial halo. Its path is one of pure, unaccompanied focus. This loneliness is a direct result of its location and size. Its small mass generates a gravitational pull that is too weak to easily capture passing asteroids or hold them in a stable orbit. Furthermore, its proximity to the Sun presents an even greater challenge. The Sun's immense gravity dominates the region, making it dynamically difficult for any small body to maintain a stable orbit around Mercury without being perturbed and ultimately swallowed by the star itself. So, unlike Earth with its single loyal moon, or Jupiter with its bustling family of dozens of satellites, Mercury moves in perfect solitude. This isolation lends its existence a special kind of calm. Its orbit is a simple, elegant ellipse, its existence uncomplicated by the gravitational tugs of companions. It is a single, silent world, circling its star in a timeless, unaccompanied waltz. Mercury can only be seen near sunrise or sunset. For ancient astronomers watching the skies with the naked eye, Mercury was a fleeting and elusive phantom. Because its orbit lies inside Earth's, it never appears to venture far from the Sun from our perspective. It is forever trapped in the solar glare, only revealing itself for brief moments shortly after sunset or before sunrise, hovering low near the horizon like a shy, bright jewel. This evanescent quality made Mercury a challenging object of study for millennia. When it appears in the western sky after the Sun has dipped below the horizon, it is traditionally called the evening star. When it shines in the eastern sky just before dawn, it is known as the morning star. Its brief, tantalizing appearances, never lasting more than a few hours, led many ancient cultures to believe they were seeing two distinct celestial bodies. Its swift motion and its role as a herald of both dawn and dusk inspired its association with messengers. The Greeks saw in it the swift-footed god Hermes, and the Romans his counterpart, Mercury. It was the celestial courier, darting between the realms of day and night, a symbol of transition and communication, bright and swift for only a moment before vanishing back into the light. Mercury moves faster around the Sun than any other planet. This association with a messenger god is profoundly apt, for Mercury is the speedster of our solar system. Driven by the Sun's overpowering gravitational pull at such close range, it hurtles through space at an average orbital velocity of 47 kilometers per second. This translates to a breathtaking 107,000 miles per hour. At this breakneck pace, it completes a full circuit around the Sun in just 88 Earth days. While its day is long and languid, its year is a frantic sprint. This incredible speed is a direct consequence of Kepler's laws of planetary motion. A planet must move faster in its orbit when it is closer to the gravitational source. Mercury, living in the Sun's immediate neighborhood, has no choice but to race to maintain its orbit. It is the fastest traveler among the planets, a silent, swift bullet, tracing the same elliptical path again and again, a constant blurring motion in the stillness of space. Mercury's orbit is the most elliptical of all planets. This path it traces is not a neat, circular course. Of all the planets, Mercury has the most eccentric or elliptical orbit. It does not travel at a constant distance from the Sun. Instead, its path is a lopsided oval. At its closest approach, a point called perihelion, it swoops to within 46 million kilometers of the solar inferno. Then, at its most distant point, aphelion, it swings out to nearly 70 million kilometers away. Mercury has smooth plains between its craters. The surface of Mercury is not uniformly rough. Interspersed among the heavily cratered highlands are vast, smooth plains. These regions are noticeably less cratered, indicating they are younger than the surrounding terrain, though still immensely old by Earth standards. Scientists believe these smooth plains were formed by massive volcanic eruptions that occurred after the period of heaviest bombardment. Enormous floods of highly fluid lava, similar to the basaltic lavas that form the lunar Maria, welled up from the planet's interior and spread across the low-lying areas, filling in older craters and creating vast, flat basins. These plains show that Mercury, though now geologically quiet, was once a world of internal heat and volcanic fury. It had an active, dynamic past where its interior melted and spilled out upon the surface, remaking its face with quiet oceans of molten stone that have long since cooled into the smooth gray plains we see today. Mercury's volcanic activity ended billions of years ago. The evidence from crater counting and geological analysis suggests that this volcanic era on Mercury was relatively short-lived, at least on a planetary scale. It is thought to have largely ended around 3.5 billion years ago. As the planet's small size allowed its interior to cool rapidly, the sources of magma dried up and the volcanic fires were extinguished. Since that time, the primary forces shaping Mercury have been external. The occasional impact from asteroids and comets and the slow global contraction as its core continued to cool. The planet transitioned from a world of fire to a world of stillness. The marks of its volcanic past, the smooth plains, remain as its final geological testament, the last major act of planetary creation before it settled into the long, quiet vigil it has maintained ever since. Mercury has polar ice, hidden in shadowed craters. One of the most astonishing discoveries about Mercury came not from visible light images, but from Earth-based radar astronomy in the 1990s. Scientists beamed radar signals toward Mercury's poles and were stunned to receive bright, highly reflective returns. The signature was consistent with water ice. This was later confirmed by NASA's MESSENGER mission. The idea seemed paradoxical. Water ice on the planet closest to the Sun? The explanation lies in Mercury's negligible axial tilt. Because the planet stands nearly straight up and down, the Sun is always low on the horizon at the poles. The interiors of deep craters, particularly at the North and South poles, exist in a state of permanent shadow. These regions are never touched by sunlight. Shielded from the Sun's intense heat, they act as powerful cold traps, where temperatures can remain consistently below minus 170 degrees Celsius. Here, water ice delivered by cometary impacts over billions of years can persist indefinitely. It is one of the planet's most beautiful contradictions, a world of blazing heat that holds frozen water in its eternal shadows, a secret hoard of ice in the furnace of the inner solar system. The ice on Mercury is mixed with dark organic material. The Messenger mission provided even more detail about this mysterious polar ice. Its data suggested that the ice deposits are not pure white, but are covered by a thin, dark layer of complex organic material. This dark blanket is crucial to the ice's survival. Scientists theorize that this material is a tar-like substance, rich in carbon, likely delivered by the same comets that brought the water ice. This dark layer acts as an insulator, protecting the underlying ice from sublimating, even if it were to be briefly warmed by scattered light or a nearby impact. It also helps to trap volatile compounds. The presence of this organic material, alongside water ice, makes Mercury's polar regions not just geological curiosities, but astrobiologically interesting sites. While no one suggests life could exist there, the presence of key ingredients for life, water and organics, in such an extreme environment expands our understanding of where these building blocks can be found in the universe. Mercury's magnetic field creates a small magnetosphere. Though weak, Mercury's magnetic field is strong enough to stand its ground against the solar wind. It carves out a protective bubble around the planet known as a magnetosphere. This region is where the planet's magnetic field dominates over the magnetic field carried by the solar wind. The solar wind, a supersonic plasma flowing from the sun, compresses the magnetosphere on the day side and stretches it into a long comet-like tail on the night side. Within this magnetosphere, charged particles are trapped, creating regions of enhanced energy. The interaction is dynamic and constant, with magnetic field lines connecting and reconnecting, releasing bursts of energy and accelerating particles. While invisible to the human eye, this ongoing silent struggle between the planet's intrinsic magnetic field and the solar wind is a testament to the dynamic and interconnected nature of our solar system, proving that even a small, quiet world can generate a sphere of influence. Mercury's exosphere is constantly renewed by the sun. Mercury's wispy exosphere is not a static entity. Its atoms are continuously being lost to space, stripped away by the solar wind and by thermal escape. Yet it does not disappear because it is also constantly being replenished. Several processes work to repopulate it. Solar wind ions can knock atoms directly off the surface in a process called sputtering. Micrometeorite impacts vaporize tiny amounts of surface material, blasting atoms into the exosphere, and the intense solar radiation itself can cause some minerals to break down and release their constituent atoms through a process called photon-stimulated desorption. This creates a delicate, dynamic equilibrium, a continuous cycle of loss and renewal. Mercury's exosphere is a breathing entity, slowly inhaling new particles from its surface and the solar wind, and exhaling them back into space, a perpetual, silent exchange with the void. Mercury has been visited by only 2 spacecraft. The profound difficulty of reaching and orbiting Mercury is underscored by the fact that only 2 spacecraft have ever made the journey. Mariner 10 was a pathfinder, a flyby mission that gave us our first glimpse. For more than 3 decades, it was our only source of direct data. The next visitor, NASA's Messenger mission, Mercury surface, space environment, geochemistry, and ranging, was a technological marvel. It took over 6 years and multiple flybys of Earth, Venus, and Mercury itself to slow down enough to be captured by Mercury's weak gravity. These 2 missions, separated by decades, represent the sum total of our close-range exploration of this world. Before them, Mercury was a blurry enigma. After them, it was transformed into a complex and fascinating world with a unique geological history and a dynamic present, a testament to how a little data can illuminate a world of darkness. NASA's Messenger mission orbited Mercury for 4 years. Messenger entered orbit around Mercury in March 2011, becoming the first spacecraft ever to do so. For the next 4 years, it was our dedicated eye on the planet, completing over 4,000 orbits. Its suite of instruments mapped the entire surface in high resolution, probed the planet's chemical composition, measured its magnetic field in exquisite detail, and confirmed the presence of water ice at the poles. It sent back more than 250,000 images, transforming Mercury from a fuzzy disk into a world with distinct personalities: rugged highlands, smooth plains, towering scarps, and mysterious hollows. In April 2015, with its fuel exhausted, the mission controllers guided Messenger to a final controlled impact on the planet's surface, where it created a new human-made crater. It was a fitting end for a spacecraft that had given so much, leaving a permanent mark on the world it had studied with such devotion. Messenger discovered Mercury's surface is rich in sulfur. One of Messenger's key discoveries was a surprising chemical signature. The spacecraft's X-ray and gamma-ray spectrometers revealed that Mercury's surface rocks contain surprisingly high abundances of sulfur, up to 10 times more than the surfaces of Earth or the Moon. This was a crucial clue to the planet's formation. Sulfur is a volatile element, meaning it vaporizes at relatively low temperatures. The fact that so much of it remains on Mercury suggests that the planet formed from building blocks that accumulated in a region that was not as intensely hot as previously thought. Alternatively, it could mean that the giant impact hypothesis, which would have vaporized away most volatiles, may need to be reevaluated. The high sulfur content influences the melting temperature of rocks and likely played a key role in the nature of Mercury's ancient volcanic eruptions. Each new finding from Messenger peeled back another layer, revealing that Mercury is far more complex and chemically unique than its quiet gray appearance suggests. Mercury's core may still be partly liquid. The presence of a global magnetic field had long hinted at a partially molten core, and Messenger's detailed measurements of the planet's gravity field and rotation provided strong supporting evidence. By tracking tiny wobbles in the planet's spin, scientists could infer the internal structure. The data indicated that at least the outer core is still in a liquid state. This was a surprise. Given Mercury's small size, it was expected to have cooled and solidified completely billions of years ago. The fact that it hasn't raises intriguing questions. Perhaps the core contains lighter elements like sulfur, which lower its melting point, acting as an antifreeze. Or maybe the heat from the decay of radioactive elements is sufficient to maintain a liquid layer. This lingering internal warmth means that Mercury is not entirely geologically dead. Its metal heart still stirs with slow, convective motion, generating the faint but persistent magnetic field that is its pulse. Mercury's surface has strange hollows. Among the most unexpected and enigmatic discoveries of the Messenger mission were features it dubbed hollows. These are shallow, irregular, bright-sided depressions, often found clustered on crater floors and central peaks. They look like the landscape is suffering from a case of cosmic acne. Unlike impact craters, hollows are not formed by collisions. The leading theory is that they are created by the sublimation of volatile materials from within the rock. When exposed by an impact or other process, these volatile compounds, perhaps sulfur or other easily vaporized minerals, are quickly heated by the intense sunlight and turned directly from a solid into a gas, escaping into space. This process leaves behind a porous, collapsed, and highly reflective surface. These hollows appear to be geologically young, suggesting that this process of loss and collapse is ongoing. They are a sign that even on this ancient, quiet world, change is still happening, not from within, but from the surface being literally baked away by the sun, leaving behind these strange, shimmering pits. Mercury's Caloris Basin is one of the largest impact craters in the solar system. we return to the Great Scar of Mercury, the Caloris Basin. With a diameter of 1,550 kilometers, it is one of the largest and most impressive impact basins in the entire solar system, comparable to the Great Hellas Basin on Mars. The impact that created it was of almost unimaginable violence, occurring early in Mercury's history. The force of the collision generated concentric rings of mountains and sent seismic waves racing through the planet. The basin floor was subsequently flooded by lava, creating the smooth interior we see today. The event was so cataclysmic that it not only sculpted the local region, but also left its mark on the entire planet, a testament to the raw power that shaped the solar system in its youth. The impact that formed Caloris Basin shaped the whole planet. The energy from the Caloris impact did not stop at the basin's rim. It traveled through Mercury's solid body, focusing on the exact opposite point on the globe, the antipode. There, the seismic waves converged with such force that they shattered the crust, creating a region of jumbled, hilly terrain, known as the chaotic terrain or weird terrain. This antipodal effect shows that a planetary scale impact is not a local event. It is a global cataclysm that can reshape a world from one side to the other. The Caloris Basin and its chaotic twin on the far side of Mercury are a linked pair, a permanent record of a single moment of extreme violence that echoed through the entire small world, a silent reminder of how energy once released must go somewhere, reshaping everything in its path. Mercury has evidence of ancient lava floods. The smooth plains that cover vast expanses of Mercury and which fill the Caloris Basin are the clearest evidence of its volcanic past. Messenger's high-resolution images and compositional data confirmed that these are indeed volcanic in origin, formed by flood basalts, enormous outpourings of very fluid lava that covered the landscape like a sea of fire. These floods likely occurred soon after the great impacts, as the planet's interior was still hot and partially molten. The lava welled up through fractures in the crust, spreading out to create vast, flat plains that buried the older, cratered terrain. These ancient lava floods are the frozen remnants of Mercury's most active period, the last great outpourings of its internal heat before it settled into the long, quiet cooling that continues to this day. What we see now are the stony, quiet remains of those once roiling oceans of molten rock. Mercury's color is slightly brownish-gray. While often depicted in artistic renderings as a silvery or chalk-white world, Mercury's true color, as revealed by Messenger's color cameras, is more nuanced. It is primarily a dark gray, but with a subtle, pervasive brownish tint. This is not the rusty red of Mars, but a more muted earthy hue. This color comes from the specific mineralogy of its surface. The dark gray is from the iron-rich basaltic rock and the fine space-weathered dust. The brownish tones are likely due to the presence of iron in different oxidation states, or from the high sulfur content, which can create brownish minerals like troilite. This soft, somber, brownish-gray palette is perfect for a world defined by calm stillness and ancient history. It is the color of age, of dust, of rock that has sat unchanged under an unblinking sun for billions of years. Mercury has subtle chemical layers in its crust. Mercury is not a homogeneous world. Data from Messenger revealed that its crust is a complex, layered structure. Different regions show distinct chemical signatures with varying concentrations of key elements like magnesium, calcium, sulfur, and potassium. These variations are a historical record. They tell scientists that the crust did not form all at once, but in stages. As the global magma ocean that likely covered the young Mercury cooled and crystallized, different minerals solidified at different temperatures and settled out, creating a crude layering. Later, the massive impacts and volcanic floods scrambled this layering, bringing deep-seated material to the surface in some places and burying the original crust under lava in others. Each chemical region is thus a page from a different chapter in the planet's cooling and differentiation history, a silent narrative written in the language of elements. Mercury's North Pole has permanently shadowed craters. The phenomenon of permanent shadow is most pronounced at Mercury's North Pole, which was the primary focus of Messenger's ice hunting observations. There, inside deep craters like Prokofiev, Kandinsky, and Tolkien, the sun never rises. The crater rims act as permanent horizons blocking the low-lying solar disk forever. These regions are among the coldest places in the entire solar system. Messenger's laser altimeter mapped the topography and confirmed the depths of these shadows, while its neutron spectrometer detected the signature of hydrogen, confirming the presence of water ice. These polar craters are cold traps, not just for water, but for any volatile compound that might find its way there. They are unique microenvironments, pockets of eternal winter in a world of fire, proving that on a planet-wide scale, local conditions can defy the global average in the most dramatic ways. Mercury's days are long, but its sunrises are short. While a full day on Mercury is interminably long, the actual transitions at sunrise and sunset are complex and in places surprisingly quick. Because of the planet's elliptical orbit and its 3-2 resonance, the sun's apparent speed across the sky is not constant. As Mercury approaches perihelion, its orbital speed increases significantly. For the observer on the ground, this causes the sun's apparent motion to slow, stop, reverse direction for a short time, the famous retrograde motion, and then resume its path. This means that at certain longitudes, you could witness a double sunrise. The sun peaks above the horizon, sets again, and then rises once more, all within the same long day. It is a strange and beautiful celestial illusion, a dance of light orchestrated by the precise mathematics of orbital mechanics, a spectacle of motion and countermotion played out against a gray, silent horizon. This 24 million kilometer variation is not just a statistical curiosity, it has profound effects on the planet's environment. The solar energy reaching Mercury at perihelion is more than twice as intense as it is at aphelion. This constantly changing distance, combined with its slow rotation, contributes to the extreme complexity of its surface temperature patterns and the strange behavior of the sun in its sky. It also means that from the perspective of the sun, Mercury's apparent size in the sky changes more dramatically than that of any other planet. Its orbit is a dance of approach and retreat, a silent, rhythmic breathing in its cosmic relationship with its star. Mercury's orbital tilt is almost zero. While Earth's tilted axis gives us the rich variety of seasons, Mercury's experience is one of eternal consistency. Its axis of rotation is tilted a mere 0.034 degrees from the perpendicular of its orbital plane. This is the smallest axial tilt of any planet in our solar system, virtually zero. This means there are no seasons on Mercury. The sun's path through the sky, the points of its rising and setting, remain nearly identical every single day of its long year. There is no summer solstice where it arcs high overhead, no winter where it skims the horizon. The only variations in light and heat come from the changing distance due to its elliptical orbit, not from a tilting planet presenting different hemispheres to the sun. This lack of seasonal shift gives Mercury a unique and profound simplicity. Its cycles are not of growth and decay, but of pure, unadulterated light and darkness, heat and cold, repeating in an unwavering, timeless pattern. The same side of Mercury doesn't always face the sun. For many years, based on limited telescopic observations, astronomers believed Mercury was tidally locked to the sun, much like the moon is to Earth. They thought one hemisphere was perpetually baked in daylight, while the other was locked in an eternal frozen night. This was an intuitive conclusion for a world so close to its star. However, in the 1960s, advances in radar astronomy revealed a more complex and beautiful truth. By bouncing radio waves off Mercury and analyzing the Doppler shift in the returning signals, astronomers discovered that the planet was rotating much faster than expected. It completes 3 full rotations on its axis for every 2 orbits it makes around the Sun. This is known as a 3.2 spin-orbit resonance. This special relationship means that while a solar day, sunrise to sunrise, is long, the same points on the surface do not always face the Sun at the same point in the orbit. Over 2 orbits, every longitude on Mercury gets its turn in the searing heat and the deep cold. This resonance is a graceful gravitational compromise, a precise rhythm that ensures no single side is permanently scorched or frozen, distributing the Sun's energy across the globe in a slow, balanced cadence. Mercury's sky is always black, even in daylight. Let us return to the thought experiment of standing on this world. One of the most striking and disorienting features would be the sky itself. On Earth, our atmosphere scatters the shorter blue wavelengths of sunlight, painting our daytime sky a familiar azure. Mercury has no such canvas. Its exosphere is too thin to scatter any significant amount of light. The result is that even under the full furious glare of a sun 3 times larger than our own, the sky remains a deep, star-studded black. You could, in theory, look away from the blinding solar disk and see the stars and planets shining with perfect, untwinkling clarity at high noon. The sunlight would be a local phenomenon, illuminating the ground and your spacecraft with brutal intensity, but it would not fill the void. The landscape would be bathed in a harsh directional light, casting sharp ink-black shadows, all set against the backdrop of the infinite starry cosmos. It is one of the quietest and most profound sights imaginable, a brilliant sunlit day happening inside an endless night. The Sun looks 3 times larger from Mercury. From this unique vantage point, our Sun is transformed. It is no longer the familiar, gentle disk we know from Earth. From the surface of Mercury, the Sun dominates the sky, appearing 3 times wider in diameter. Its area in the sky is nearly 10 times greater. This, combined with its proximity, means it shines with a ferocious intensity, pouring out 7 times more light per unit area than it does at Earth. If you could safely gaze at it, which you could not without severe eye protection, you would see a luminous sphere of overwhelming brilliance, a golden white furnace whose surface details might even be discernible to the naked eye. Its light would not be the warm, life-giving glow we know, but a searing physical force. As it rose with its slow, stately pace, the heat would begin to shimmer off the cratered ground, not through heated air, but through thermal radiation from the superheated rock itself. The space around you would remain perfectly still and silent, but the Sun would feel closer, heavier, more present, and demanding than it has ever felt anywhere else. It is a world where the star is not just a feature in the sky, but the defining, overwhelming reality of existence. Mercury's year is shorter than its day. This is perhaps one of the most counterintuitive and beautiful facts about Mercury, a perfect illustration of how our earthly perceptions fail in the cosmos. We are accustomed to a day being a small fraction of a year. On Mercury, this relationship is turned on its head. Because of its 3.2 spin-orbit resonance, a single solar day on Mercury, the time from one sunrise to the next, lasts 176 Earth days. Meanwhile, its year, one complete orbit around the Sun, is only 88 Earth days. Therefore, a day on Mercury is exactly twice as long as its year. The planet experiences 2 full years in the time it takes for the Sun to complete one apparent cycle in its sky. This rhythm feels deeply unearthly, a temporal paradox where the concepts of day and year lose their familiar meanings. Time itself seems to bend to the complex gravitational interplay between the planet's slow spin and its rapid orbital sprint. Mercury has no true weather on Earth. Our landscapes are shaped by a constant dynamic force, weather. Wind, rain, ice, and waves tirelessly sculpt the mountains, carve the valleys, and fill the oceans with sediment. Mercury knows none of this. It is a world of geological stasis. With no atmosphere, there is no weather. No clouds ever form in its black sky. No wind ever whispers across its plains. No drop of rain has ever fallen to erode its ancient features. The dust that lies upon its surface is not blown into dunes or washed into strata. It settles and remains, undisturbed for eons. If an astronaut were to leave a footprint in the fine regolith today, that print could potentially remain perfectly preserved for tens of millions of years until a rare meteorite impact or the slow creep of the soil under the sun's thermal stress gradually obscures it. This utter lack of weathering makes Mercury a pristine time capsule. It is a museum of the early solar system. Its exhibits, the craters, the cliffs, the plains, frozen in a state of arrested development, telling an unedited story of cosmic violence and planetary formation. Mercury's surface is mostly gray rock and dust. The first close-up images from Mariner 10 and later Messenger revealed a world of muted, somber tones. Mercury's surface is not a vibrant tapestry of color, but a landscape of grays. It is composed primarily of silicate rock similar to the rocks of Earth, but darkened by a fine iron-rich dust and the effects of 4 billion years of exposure to the harsh space environment, a process known as space weathering. Its albedo, or reflectivity, is very low. It reflects only about 10% of the sunlight that strikes it, making it only slightly more reflective than a fresh asphalt parking lot. This dark ashen hue contributes to Mercury's calm and solemn appearance from space. There are no bright white ice caps, except in the hidden polar craters, no ruddy iron oxides like on Mars, no variegated mineral streaks. It is a world of subtle shades and textures, a monochromatic masterpiece of quiet gray landscapes stretched beneath an endless black sky, a study in minimalism on a planetary scale. Mercury has long, high cliffs called scarps. As our orbital gaze sweeps across the globe, we notice features that are not craters, long, sinuous lines that snake across the surface, cutting through plains and even through the rims of older craters. These are lobate scarps, enormous cliffs that can be hundreds of kilometers long and rise over a kilometer high. They are one of the most widespread and telling landforms on Mercury. These scarps are tectonic features, the wrinkles of a shrinking world. As Mercury's massive iron core slowly cooled and solidified over billions of years, it contracted. The planet literally shrunk in on itself. The brittle crust, with nowhere to go, had to accommodate this global reduction in size. It fractured and was thrust upward, one block of crust riding over another, creating these immense lobate-shaped cliffs. The presence of these scarps, even slicing through young craters, tells us that this global contraction has been a long and ongoing process. Mercury is not a static world. It is a world that is still, ever so slowly shrinking and wrinkling with age, a silent planetary scale transformation that continues to this day. Mercury's gravity is about 38% of Earth's. If you were to step onto the surface of Mercury, your first sensation would be one of lightness. The planet, OS small mass, results in a surface gravity that is only 38% of what we experience on Earth. A person who weighs 100 kilograms on Earth would feel as though they weigh only 38 kilograms on Mercury. This reduced gravity would transform your movements. A simple step would become a bounding, low-gravity lope. You could jump 3 times higher than you can on Earth, soaring over small craters and boulders with an effortless grace. While the landscape is rugged and treacherous, the act of moving across it would feel light and smooth, almost like slow motion. Your movements would be dictated by a gentle but persistent pull, a constant reminder that you are standing on a small world, one with a weaker grasp on you than the home you left behind. Mercury is the second densest planet. This sensation of lightness on the surface belies the true nature of the world beneath your feet. Despite being the smallest planet, Mercury is extraordinarily dense. With an average density of 5.43 grams per cubic centimeter, it is the second densest planet in our solar system, trailing only Earth. When you adjust for the fact that Earth's density is increased by gravitational compression, Mercury likely has the highest uncompressed density of all. This high density is the direct result of its colossal iron core. It means that the mass of Mercury is not distributed evenly throughout its volume, but is overwhelmingly concentrated in its metallic heart. It is a small planet that punches far above its weight, a dense sphere of heavy metal thinly veiled in a cloak of rock. This hidden density is the source of its gravitational field and its geological history, the fundamental truth of its composition. Mercury reflects light poorly. This dense, rocky surface is a poor mirror for sunlight. Its low albedo of around 12% makes it a challenging object for Earth-based astronomers to study. It is not only small and close to the sun, but it is also intrinsically dark, making it difficult to discern against the bright twilight sky. Yet, when conditions are perfect and it is caught in a telescope at dusk or dawn, it glows with a soft, steady gray light. It does not twinkle like a star, for it is a tiny disk, but its light is calm and subdued. This faint glow, the reflected light of a distant, airless world, is a subtle invitation to look closer, to peer past its dim appearance and discover the complex and fascinating world that lies beneath its muted facade. Mercury's orbit slowly shifts over time. The story of Mercury's orbit is not just one of a fixed ellipse. Like all planetary orbits, it undergoes a slow precession, meaning the ellipse itself gradually rotates around the Sun. For centuries, astronomers meticulously tracked Mercury and found that its perihelion, its point of closest approach to the Sun, was advancing slightly faster than could be explained by the gravitational perturbations from the other known planets, according to Newtonian physics. This tiny discrepancy, a mere 43 arcseconds of precession per century, was a nagging, unsolved puzzle in celestial mechanics. It was a puzzle that required a revolution in physics to solve. When Albert Einstein developed his theory of general relativity, he used the orbit of Mercury as a key test. His theory proposed that gravity is not a force acting at a distance, but the curvature of space-time caused by mass. The Sun's immense mass creates a dimple in space-time, and Mercury, orbiting so close, experiences this curvature most strongly. The extra precession Einstein showed was precisely what his equations predicted. Mercury's tiny orbital anomaly became the first solid observational proof of general relativity. In this way, the small, innermost planet played an outsized role in confirming one of the most profound and beautiful theories of the modern age, helping to redefine our very understanding of space, time, and gravity. The first spacecraft to visit Mercury was Mariner 10. The journey from mathematical prediction to direct observation began in earnest with the dawn of the space age. The first emissary from Earth to visit Mercury was NASA's Mariner 10 spacecraft. Launched in 1973, it executed a brilliant and pioneering maneuver. It used a gravity assist from the planet Venus to bend its path inward toward Mercury. This made it the first spacecraft to visit two planets on a single mission. In 1974, Mariner 10 made the first of 3 flybys of Mercury, capturing the first close-up images in human history of this cryptic world. The pictures that streamed back to Earth revealed a heavily cratered moon-like surface, confirming its ancient and inert nature. Mariner 10 mapped about 45% of the planet's surface and made the first detection of its magnetic field and tenuous exosphere. For over 30 years, the grainy black and white images from Mariner 10 were our only window onto Mercury, defining its image in the public and scientific mind as a quiet, gray, and geologically dead world. Mercury was known since ancient times. Long before Mariner 10, long before telescopes, Mercury was a familiar, if elusive, sight in the heavens. It is one of the 5 planets visible to the naked eye, and it has been watched by humanity since the dawn of recorded history. The Sumerians, the Babylonians, the Egyptians, and the Greeks all recorded its movements. Its swiftness and its habit of appearing in 2 different parts of the sky led to confusion. The Greeks, for a time, believed they were observing 2 separate celestial bodies. They named the one that appeared in the morning sky Apollo, after the god of the sun and light, and the one that appeared in the evening Hermes, the swift messenger of the gods. It was the Greek astronomer Pythagoras who is often credited with first realizing that these 2 apparitions were, in fact, the same planet. This discovery was a crucial step in understanding the structure of our solar system, linking the morning and the evening into a single, wandering star. The Romans named Mercury after their swift messenger god. The Romans, inheriting much of their astronomical knowledge from the Greeks, adopted this understanding and gave the planet its permanent name, Mercury, after their own swift-footed messenger god, the equivalent of the Greek Hermes. Mercury was the god of commerce, communication, and travel, known for his speed and cunning. He was often depicted with winged sandals and a winged helmet, symbols of his rapid transit between the worlds of gods, humans, and the dead. The name was perfectly suited to the planet's observed behavior, the fastest-moving planet in the sky. This connection between motion and communication endures to this day, not only in the planet's name but also in the element mercury, the liquid metal once known as quicksilver for its fluid, swift mobility, a direct reference to the planetary namesake. Mercury's surface is older than Earth's continents. The surface we see today when we look at Mercury is unbelievably ancient. Most of its crust solidified and was heavily cratered during a period known as the Late Heavy Bombardment, around 4 billion years ago. This makes the vast majority of Mercury's surface older than the most ancient rocks found on Earth. On our dynamic planet, the relentless engine of plate tectonics constantly recycles the crust, swallowing old seafloor and creating new land through volcanic activity. The processes of erosion by wind and water continuously reshape the continents. Mercury has none of this. Its geological activity ceased billions of years ago. Its crust is a single solid shell. As a result, its landscape is a preserved relic. Looking at Mercury is like opening a time capsule and gazing upon the solar system as it was in its violent infancy, a primordial state of being, quiet and raw, that has been lost on every other rocky world. Mercury's craters are named after artists and writers. In a beautiful tradition that links human culture to the cosmos, the International Astronomical Union names Mercury's craters after famous artists, musicians, painters, and authors. As you scan a map of Mercury, you will find the names of great creative minds etched into its surface for eternity. There is the crater Beethoven, honoring the composer who transcended his deafness. There is Shakespeare, the master playwright. There is Dickens, Tolstoy, and Bronte. There are painters like Van Gogh and Hokusai, and composers like Mozart and Sibelius. This tradition is a tribute to the human spirit of creativity and exploration. It reminds us that our journey to understand the universe is not just a scientific one, but also a deeply humanistic endeavor. Each named crater is a monument, a quiet tribute to art and imagination carved in sun-baked rock and shadow, a permanent fusion of culture and cosmos. Mercury's rotation was measured by radar from Earth. The discovery of Mercury's true rotation period is a classic story of scientific ingenuity. Before the space age, the 3-2 resonance was unknown. In 1965, astronomers Gordon Pettengill and Rolf Dice, using the giant Arecibo radio telescope in Puerto Rico, performed a brilliant experiment. They beamed a powerful radar signal at Mercury and analyzed the Doppler broadening of the returning echo. As the planet rotated, one edge was moving toward Earth while the other was moving away, which smeared the radar return. By carefully analyzing this smear, they could calculate the rotation rate. Their results conclusively showed a period of 59 days, definitively disproving the old tidal lock theory and revealing the elegant spin-orbit resonance. It was a triumph of remote sensing, a discovery about the fundamental nature of a planet made from 30 million miles away, without ever leaving Earth. Mercury's surface reflects ultraviolet light. Messenger carried an instrument called the Mercury Atmospheric and Surface Composition Spectrometer, MASCS, which studied the planet in different wavelengths of light. It discovered that certain areas on Mercury's surface have unusual spectral properties, reflecting ultraviolet light more strongly than expected. These ultraviolet blue spots are often associated with the mysterious hollows and are thought to be related to the fresh, unweathered material exposed by the sublimation process. Different minerals reflect light in unique ways across the electromagnetic spectrum, and these ultraviolet reflections are like a fingerprint, helping scientists identify the specific minerals present. It shows that even under the harsh, unrelenting solar radiation, Mercury's surface minerals still possess subtle and diagnostic optical properties, revealing their composition to those who know how to look. Mercury's gravity helped refine Einstein's theory. We return to the pivotal role Mercury played in the history of physics. The unexplained precession of its orbit was a tiny anomaly, a 43 arc-second per century discrepancy that Newton's laws could not explain. It was a loose thread in the fabric of classical physics. When Einstein developed the equations of general relativity, he found that they predicted an extra precession for a planet in Mercury's orbit due to the curvature of spacetime around the Sun. He calculated the value, and it matched the observed anomaly perfectly. The moment he saw this, he reportedly felt his heart palpitate, knowing he had found a key to the universe. The orbit of Mercury, a small wobble in the path of a small planet, became the first observational validation of one of the most profound theories ever conceived. In this way, Mercury, the innermost planet, helped to prove that space and time are woven together in a curved fabric, forever changing our understanding of the cosmos. You've just traveled across Mercury, a planet of silence, light, and time. You have felt its extremes, traced its ancient scars, understood its hidden heart, and followed the human story of unraveling its mysteries. As your mind drifts deeper into rest, remember, the universe is not only filled with movement and noise, but also with stillness and peace. If these quiet wonders of the cosmos help you unwind, consider supporting our journey. Subscribe to The Sleepy Scientist for more peaceful explorations, and share this channel with a friend who needs a moment of celestial calm. Thank you for listening. Good night, traveler of the stars. May your dreams drift through the quiet light of Mercury.